Welcome. On this function, we're going to be discussing the intermediate value theorem. So let's get started. So what exactly is the intermediate value theorem? Well, for that, let's take a look at this illustration right here. So let's consider a continuous function, and let's call it f of x, which right here, we do have an illustration of that f of x. So here we have a function where notice that this function, it is defined between the intervals of a and b. Now, very important, for the intermediate value theorem to be true, this function needs to be continuous. Now, for notation purposes, let's call this point, well, this point, we can see that the y value, it is just f of a. That's the notation that we'll be using, because notice that if this is a, and this is the function of f of x, then therefore, if I plug this a to the function, I get f of a out. And now, for the other point as well, for this point that we do have here, let's call that function, or this point right here, let's say that this is f of b. Because note that this is the y value. So if I get b and I plug into the function, so that is f of b. So now this is the notation we'll be using. Now, what exactly does the intermediate value theorem says? Well, the intermediate value theorem says is the following. So here we have a function that is defined between a and b, and we also have some y values, f of a and f of b. What the intermediate value theorem says is that I can choose any y value between f of a and f of b. Any y value. I'm just going to choose it right here. So let's choose this point right here. Let me call that y3. So what the intermediate value theorem is saying is that, look, choose any y value between f of a and f of b. I can assure you that I can find any x value between a and b that will give me that y value out. So again, here we have a continuous function, and I know that this continuous function, it is defined between on the x values between a and b, and the y values between f of a and f of b. What the intermediate value theorem is saying is that any y value between the two known y values, I can find an x value between a and b that can give me the y value, which we call y of 3. And that's all the intermediate value theorem is saying. For any continuous function, choose any y value between the two known y's. I can always find an x value that I can plug into the function that will give me the output of the y that is between f of a and f of b. So let's just put that into writing. So it says for any interval, which we call a and b. So for any interval of a or b, well, if there is a y value, which we call it y3, between f of a and f of b, then there exists a value, let's call it x in this case, where this x is between a and b, such that f of x gives me y of 3. So this is how we can interpret the intermediate value theorem. But now notice that for the intermediate value theorem to be true, we have to assume that f of x is a continuous function. So what happens if we don't have a continuous function? Does the intermediate value theorem still hold true? Well, let's take a look at these two scenarios. So does the intermediate value theorem work if the function is discontinuous? And for the function to be discontinuous, we could have two scenarios, where the first scenario is that we have a hole on the graph. Or we have a discontinuous point. So let's assume that, we have a hole right here. Let's assume that this point is not solid, but it's actually a hole. Well, the same idea, this is this is f of a, and this is f of b. So what the intermediate value theorem is saying is that, well, any value that is between f of a and f of b, I can always find a x value between a and b that I can plug into the function and will give me that y out. Well, notice that that's not exactly true if we have a hole on the graph. Because what if we're interested on the y value where we have that hole? So what if we're interested on the y value where we have a hole in the graph? But notice that that's just not possible. Because if there's a hole, that means that x, it's not part of the domain. Then in this case, the intermediate value theorem is not true, because the intermediate value theorem says that for all y values. So notice that I'm saying for every single y value between f of a and f of b, I can always find an x that I plug into the function that can give me that y value. But notice that right now I'm choosing this one, and there is no x value that I can plug into the function that will give me this output, because we know there's a hole. Therefore, the function is discontinuous at that point. So notice that this is one scenario. This is why we have to put emphasis on the function being a continuous function, or else we can encounter situations of this form. So therefore, since the function is not defined at, well, let me call this x. Let's actually call this x1. At x equals x1, then the value f of x1 is just undefined. So notice that this is why the function needs to be continuous, or else we can encounter situations of this form. And what's another way of making our function to not be continuous as well? Well, we could have some kind of a jump discontinuity. So let's assume that now this ending right here, it is actually a hole, and now it's just filled somewhere over here. Now let's think about this scenario. Still, it's the same idea. It is a function that is defined between f of a and f of b. So notice that now here, this is still my f of a. And now at b, it's a little bit tricky, because at b, it is not defined here. It is defined all the way over here. So this will be my f of b. This is my f of b. And the intermediate value theorem is saying that any value between f of a and f of b. But notice that I can choose, let's call my y of 3 to be somewhere here. Let's say that I'm interested on this y value, because again, this y of 3 is definitely between f of a and f of b. So it meets the criteria of the intermediate value theorem. But notice that there is no x value. There is no x value between a and b that will give me that y3 out, because there's just simply nothing in this space right here. Notice that this is just blank. There is just blank space right there. So y of 3, it is still between f of a and f of b, but notice that there is no x value between a and b that will reproduce y3 as an output. Therefore, notice that y of 3, it is still between f of a and f of b, but there is no x1 value between a and b that have y3 as the range. So this is why when we talk about the intermediate value theorem, the function needs to be continuous, or else we can encounter these two type of situations. Either there's a hole or if it is some kind of a jump discontinuity. So that is the intermediate value theorem. So now the question is, how is this useful? Because this is just a theorem. We have not used any applications. Well, let's take a look at a small application of it. So how can we use the intermediate value theorem? Well, it says, let's show that the function, so here we have a function, has at least two real zeros between x1 and x4. And let's graph the function to verify our results. So again, we're not interested on what are the zeros, but we're just interested on show me that there is at least two real zeros between 1 and 4. So how can we show that? Well, I mean, if you graph it, you can just look at the graph and verify yourself. But what if you don't have a graphing calculator? Well, one way to do it is by using the intermediate value theorem. So let's just create a table of values. Let me just go back to the regular color here. So let's just create a table of value. And notice that I'm interested on the values between 1 and 4. So let me just create my table of values here. So I'm just going to choose in values between 1 and 4. So I'm going to start with 1, and then 2, and then 3, and then 4. And I think I just went overboard. So let's just ignore that section right here. And you can verify these results. But if we would have plugged in 1 to the function right here, we would have gotten a 5 out. If we would have plugged in a 2 to the function, we would have got a 0 out. If we would have plugged in 3 to the function, we would have got negative 3 out. And if we would have plugged in 4 to the function, we would have got a 2 out. So now notice that we have a coordinate point. And let's call this points. So let's call this point A, let's call this point B, and let's call this point C and D, where A has a coordinate point of 1, 5. So let's plot that. So let's plot our point A, which is at 1, 5. So 1, 1, 2, 3, 4, 5. So here we have point A. Now for B, we got 2, 0. So 2, 0. For C, we got 3, 1, 2, 3, negative 3. And for D, we got 4, 2. Now, we can see one solution right here. So notice that here we have one solution. But where else can we have another solution? Well, let's take a look at the point C and D. Well, the intermediate value theorem, well, we know that f of x is a continuous function. F of x is a continuous function. And I know that if this function is continuous, notice that the 0, it is the y value between D and C. So I know that if I choose a y value between D and C, which in this case, the y value that we're interested on is 0, which is definitely between C and D, there must be an x value that will give me that output. And that's exactly what we're looking for. What we're looking for is not exactly what is the y value, what is the x value, but more than anything, we know that there must be another solution here. Because since this function is continuous, therefore, there must be a y value between C and D, which is the solution that we want to, and that y value will exist. And as a matter of fact, there will be an x value that will give me that y value, which is 0. And again, we're not interested on what is that x value or what is that solution, but we're just interested on what is or how many solutions can we get from here. And another way to visualize this, since we know that this is a continuous function, so therefore I can just connect all those dots. And I can see that my function will pass through my solution somewhere in here. So let's just write that in there. So we know that since we know that f of x is continuous, then by the intermediate value theorem, then we are guaranteed a solution between points C and D. Well, another way to interpret this is the following. Just take a look at the y values. At least for point C, the y value here, we have a negative y value. And for point D, we have a positive y value. And for you to go from a negative to a positive, you must pass by 0. So therefore, you must pass by one of the solutions. So the intermediate value theorem, it states we have a solution here, and well, the second solution is point B. So this is one way that we can use the intermediate value theorem to estimate how many solutions we can encounter in a function. If we go from a negative y value to a positive y value, we must pass by 0. So therefore we have one solution here, and it is clear that B is another solution. So with this, it concludes our lesson with the intermediate value theorem.